3 minutes.
Sure. Hello to everybody. I hope all of you are fine, and I'm pleased to be here.
Thank you so much. Yeah, put a bunch of reactions to our dear speaker. He shared with you a lot of important information and a lot of useful information. So I hope you all already have your notebooks and laptops to make a conspect. I'm sure the information will be super useful. So, dear Mr. Muhammad, if you need a presentation, please feel free to share it. I think Mr. Dayanam already gave you the opportunity to share. If no, it's okay.
Sure. I think I don't have access to share. Can you please allow me to share?
Sure, dear Mr. Dayan, I'm asking you, please kindly to give the right to share presentation to our dear guest. And guys, while we're deciding with technical issues, I will ask you to tell to your friends who are not here yet, but we already started because the session gonna be useful, the session gonna be important for you and your future career. So please invite everyone. If there is anyone who didn't join yet, we are waiting for you. So do you have right now? It's okay?
It's still showing that I'm unable to share for some reason. I can see the tab, but when you share it, that is grayed out.
Okay, we're deciding. You can also send your presentation to me, so I will share it in our technical support. I will share the presentation. You will just tell me which slide we will need to open.
Sure, I will do that. It's a bit big file, so it will take some time for to send you and so forth.
Okay. Also, maybe you need to join us again because actually our technical support were telling that they gave you the right to share the presentation. So maybe you should re-enter to via the link to our session, and you will have an access to.
I will do that. I will do that again. Okay,
Yeah,
let me just
thank you.
Thank you.
Sure. So guys, how is your mood today? Give me a bunch of reactions. Wow, 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 wow. Okay, okay, okay. Someone have a really good day today. Okay, okay, that's good. Okay. I'm happy for you, by the way. It's a middle of the week. I'm already a little tired, but it's a lot, I'm enjoying when I'm seeing your reactions because it's really making me a lot happy that someone have a good day. Okay, we can see the slides now, dear Mr. Muhammad. That's good.
Perfect. So are you
So,
able to see that?
yes, yes, yes. We're able to see.
Okay.
Just if you can make it full screen, maybe.
Okay, perfect. Can you see it now? That's better. Yeah.
Yeah, that's wonderful. So I think we can start. I will introduce you now to our participants. It's my pleasure, guys, to introduce you our today's expert speaker, dear Mr. Muhammad Hussam. He is an instructor at Abu Dhabi Polytechnic University, and he holds an MCS in energy technology and has hands-on industry experience as a former Baker Hughes professional. And today he will speak to us about process safety and operational excellence in real plant operations. And you know, this is the kind of knowledge that turns theory into real industry. So, Mr. Muhammad, I would like to thank you again again for joining us today. We really appreciate and we're really glad to have you here with us. And the floor is yours. I'm stopping to talk right now. Guys, also, last thing which I would like to mention, we will have a Q&A session in the last couple minutes of the session. So please write your questions in chat, and in the end, we will answer to them. Also, you will have an opportunity to personally ask the question to our speaker. So right now, dear Mr. Muhammad, the floor is yours.
Right there. Good day to everybody. I hope all of you are fine, and I'm pleased to be here. And thank you for this opportunity. It's always good to interact with the young, students and young people and share your knowledge. It's an amazing thing. And also thank you, RTsim, for collaborating with Abu Dhabi Polytechnic. We'll be doing more good things in the future as well, and so forth. So a bit about myself. I'm currently working as an instructor in petroleum engineering technology in Abu Dhabi Polytechnic. It's a government institute. We trained local Emirati students. Before joining Abu Dhabi Polytechnic, I was working as a logging engineer for Baker Hughes. I worked there for 6 years. I have a bachelor's degree in geoscience. Mostly it was petroleum geology, and I did some work related to structural geology, stratigraphy, some hard rocks work there. And then I moved to UK for a master's degree. There I did master's in energy technology. It was a mix of sustainable energy, contaminated landfill engineering, and a bit of geotechnical that I did, and so forth. And then I moved to UAE, and since then I'm in academia, and I'm enjoying here. So today's topic is quite interesting, which says process safety in engineering and the environment. So what I've done is I'm not purely focusing itself on the safety. I'm trying to link it with the environment as well. That all these processes, they're linked with environment. So we'll talk on both aspect of the process safety itself. We'll also look into some of the case studies where how those case studies have led to what process safety, what we have, what we're seeing right now. There are multiple domains of process safety. You can work in various different organizations, from specifically related to oil industry, as you're aware that we have upstream, midstream, downstream. So the safety aspect is there almost everywhere. We have to do the exploration in a safe way. We have to drill the well in a safe way. We have to case the well in a safe way, and then production. That production, it has to be transported, it has to be stored in a safe way, and then refined, distributed across. So there are multiple different domains where the safety aspect is there, and it's a very broad aspect. But if you think about the safety, it has to be everywhere. And when we talk about operational excellence, it comes with the everything is linked with safety. If we do things in a safe way, the organization is going to be, the operational excellence is going to be there, the profitability is going to be there. If you're taking consideration of environment, we are taking care of the environment as well. So all of that is linked with what we are doing. We have to see what are the processes are to deal with, and so forth. So since I'm from academia, so we design the lectures based on what are the objectives and what are the let's say what are the outcomes of the lectures there, and so forth. So we'll start with the let's say, what is process safety engineering? What is process safety? Why are we considering process safety? Evolution of process safety. And there is case study of BP Texas refinery. I think all of you are aware of that there was a very disastrous fire, and that led to so many lives were lost, so many infrastructure was lost as well. So we'll try to see what was the cause of that, why that happened, and so forth. And we also need to link it with the environment. All these processes, all these operations, they're linked with environment in one way or another. Are we taking into consideration that our actions, do they have any impact on the environment? Have we done proper impact assessment? Have we done, we looked into what are the hazards associated, and so forth. So all these process plants, all these refineries, all these overall infrastructure, it has an environmental impact. So it has to be considered, how it will impact the overall environment. So you're hearing in all sorts of different seminars, symposiums related to energy transition, related to green energy, related to saving the environment, saving the planet. Um, it all boils down again to the operational excellence, that how that operations or how that process has been designed, that it has a minimum impact on overall environment and so forth. Um, so we will try to look into overview of the process safety, safety engineering, and then process safety and personal safety. When we say, operational excellence, it has to do with the competent people as well. Are they trained enough? Do they have the right skills to run that process? Are they, is there any training protocols that are there? Do we have any safety protocols in the environment, in that very environment that we're working in? So these things are linked together. So we have to see in a broad perspective that how these things are linked and so forth. Now, going directly into the outcomes and so forth. So we want you to understand the process safety engineering, the consideration, the relationship between the engineering and environment, how the process safety and person safety is linked, and what are the, in a simplest way, what are the major root causes of any disaster that can happen. It can happen in upstream, it can happen in midstream, it can happen in downstream. It's everywhere. So we have to consider the operational excellence and so forth. I'll just jump straight to the topic there. So what exactly is process safety, and how is it linked with the operational excellence, and so forth? So we can have multiple different things that can go wrong. We can have various different accidents. We can have explosive materials that we're dealing with. We're dealing with high pressures, high temperatures, high flow rates, high levels. We're dealing with chemicals, different dangerous, different substances and so forth. So overall, in a safe manner, just like I'll give you an example of when you're going to get a driving license. You go through a theory test, you go through a practical test, and then you go to a test itself, and then you get a driver's license. Even you get a driver's license, your first few years, you're very, very cautious about things can go wrong, how am I supposed to turn left and turn right and so forth. This is just a very, very minor thing, a very small process, but it has lots of implications. If you don't drive safely, you're putting others' lives in danger as well. You're dealing with, let's say, you can damage your own car, you can hurt yourself as well. So we have to consider the excellence in the process. We have to understand what we are trying to achieve, what exactly is the objective of the overall that process that we're dealing with. There are technical aspect of safety, and then there are management aspect of the safety as well. So it has to be considered as a full-on, let's say, spectrum, where we're dealing with engineering skills, management skills, and managing the workplace safely and effectively. As I said, we're dealing with lots of different hazards in terms of manufacturing facilities, in terms of processing facilities, in terms of hazardous chemicals that are there. Maybe we're working at heights and so forth. Specifically, if you're working with in an offshore environment, we have to consider the overall the safety of the process, and at the same time, we have to consider the deliverables. The organizations and the nations, they don't invest in something which they feel that they're not going to get the return back. So if we are not doing in a safe way, if we're not doing in a manner that it's supposed to be done, then overall productivity will go down, profitability will go down. We are exposing public, we are exposing our infrastructure, we are exposing our assets, and also an environment to a very a situation which could be hazardous and which could be dangerous as well. So we have to define the safety element, we have to define the excellence element, and then see where we are, how the overall process is designed, it's managed. It's a continuous cycle. where we monitor, we learn from the mistakes, we report it, and we'll try to improve it. In the later half of the presentation, we'll see there are some excellence, let's say, protocols in terms of management, in terms of personal safety aspects that we'll look into in a bit more detail. So when we say about engineering itself, we have to consider the design and analysis of the process equipments. We are dealing on a daily basis with them, risk associated. And there are multiple different examples, if you look around yourself as well on a daily basis, that are dealing with safety. We go to the doctors. Doctors have to be competent enough to give a proper, let's say, treatment. If there is a surgery, then a minor mistake can lead to again a very serious health situation as well. So similarly, if we are not designing our process plant or designing our facility in a safe manner or in a proper way, it might lead to a very disastrous situation. So whenever any process facility is designed, they consider the worst case scenario, that what could possibly go wrong, and do we have any contingency plans for, let's say, plan A, plan B, plan C? Do we have the dedicated people who will respond to that let's say unexpected situation? Do we have, let's say, sensors in place, or do we have the system in place which can inform us at the right time, so we can save the overall process? And the processes are linked with each other. So we have got, let's say, you take an example of drilling. Everything is integrated with each other. If the BHA is not working, or if the BHA is clogged, it has an implication in overall drilling of the well. If for some reason annulus is blocked, we are not circulating properly, that has also implications. If the drilling fluid mud or the drilling mud, it's not the right density or the right specific gravity, we are losing hydrostatic pressure. So that all of that thing, it goes down to everything is linked together. So when you design it, you design every element in the right way, and everything has to complement so that the overall process is as safe as possible. Why I need to consider process safety or process excellence? Threat to serious injury or fatalities, loss of production, legal actions. So these days, the different nations, they are very crude about lots of safety regulations, and if you're not doing it in a safe manner, then there are legal implications as well. You have to pay hefty fines. There are lots of examples where there were spills in the seas, and the companies have to pay literally billions of dollars as part of the legal action that was taken by the nations. The overall company's reputation, it can be damaged right away, that this company is not working in a safe manner. They don't have the right skills, or they don't have the right attitude to work in a proper way. And all these big infrastructure facilities, they're insured. So your insurance premiums, they can go high as well. Loss of lots of assets that can be there, and so forth. So there are lots of considerations that we have to. You're a student, and you're working or you're studying in different domains. So we have to consider all these safety aspects and so forth. So there are a couple of, let's say, some questions for you. Let me just, if you can please scan this QR code quickly, and then let's see what do you understand about these very simple basic questions. If I can request all of you to please scan this QR code, and let's see if you have any participation there. We have 12 participants. If we can just quickly try to do that, please. So what is the most significant long-term impact of a hazard or a workplace fatality? So what do you think? It's an immediate loss, equipment downtime, psychological impact, or temporary media attention? What do you think? I would like to see your participation there, please. So
Yes,
just
yes,
scan
you
this.
can write in chat. Yeah. If you have any issues, just try to send this QR code. It's being Muhammad. I hope everything will be okay.
So just wanted to refresh and see if there's any response. Sometimes response comes a bit late. We can have a yeah. So
Yeah, we have one response in chat to you, Mr. Muhammad. I think it's for our
okay, it's
participants.
okay. It's, if there's an issue, I can move forward. It's just to interact with the students to have
Yeah,
this.
sure.
Uh,
It's
that's okay. We
wonderful,
can move on.
actually.
We can move on to that. So evolution of process safety. There are various different events that have led to where we are right now. We have various different disasters that have led to, let's say, management system failures, hazards that are not identified, risk assessment not done properly, management of change that has not been done, and so forth, permit to work system that were not implemented properly. So we have learned so much as part of the process excellence and over the years. And there are different disasters that have led us to basically understand where we are in terms of safety as of now. These are some of the case studies which have various different events that have happened over the years. There was in 1974 the Flixborough event. It led us to understand what hazards are, what are management of change, impact, and so forth. We had the Seveso in 1976, where lots of chemicals were released, and there were protocols established related to vapor cloud explosions. Then in Mexico City, there were boiling liquid expansion or vapor explosion and so forth. That has also led to understanding the protocols about how the liquid has to be expanded or it's stored and so forth. Um, then there were some refineries incidents, specifically Bhopal, and then BP Texas refinery as well, that has led to a very serious consequences and so forth. Piper Alpha, that is a platform offshore oil rig that was burned. That also had lots of consequences there and so forth. So the safety process or the excellence process has evolved because of these incidents. Each incident is a is an excellent case study to understand what went wrong, why that has led to where we are and in that particular situation. So if you're in your free time, you can take I can share this presentation with you. In that there are very detailed links related to these documentaries, and you watch those documentaries and ask yourself questions that why has that happened, what could have been done in order to save it, specifically related. It is from upstream, midstream, downstream, related to refineries. So there are literally tons of literature available, and also lots of documentaries are there, short documentaries, 5 minutes, 6 minutes, and it will really let you understand what went wrong and so forth. Um, this was a Chevron Richmond refinery. Here, if you watch this short video, and after that you can think what impact it had on the environment and what management did. They already knew there was significantly something wrong in the distillation column, and they did not looked into the overall, let's say, maintenance of it, record of maintenance, and these incidents could have been avoided. Um, just because we don't have let's say the right attitude at that moment. We did not you know to because of the cost implications, because of the management issues, it has led to very serious implication, and that has both the damage of the equipment, loss of property, loss of the lives, overall it has happened. um, there are you know Personal safety and process safety, both of them, they're linked together. In terms of process safety, we have to consider um, what processes, what are we dealing with? Are we dealing with extremely dangerous, let's say, chemicals? We're dealing with high temperatures, we're dealing with high pressures, we're dealing with overflows, we're dealing with, what exactly the overall objective of the process is. Um, and also what can go wrong. Do we have right knowledge? Do we have right experts? Do we have all of the, let's say, right tools available? Do we have training infrastructure? Do we have, let's say, continuous improvement, and so forth? And this is expensive thing. And as I said before, that the companies do not want to invest in something where they feel that the returns are not going to happen. If you're keep on, as a businessman, you start a business and you put in certain sum, and at the end of the month you're expecting a certain return. If the return is not there, it means that your business is in loss, and you want to look into some other, let's say, other resorts, or let's say, other potential businesses which can give you a return. So similarly, if the process operational excellence is linked with the process safety. If we are not working safe, we are there will be lots of downtimes. There will be people who are, there will be lots of injuries. There will be high insurance premiums, and it's overall it will be expensive. And personal safety, it's about making people aware to work safe. We have very simple things like slips and trips and falls. We can have a low impact, high impact, low frequency, high frequency. What are the likelihoods? And this is where the risk assessment comes in, and hazard identification, and so forth. So when a person is hired, he goes through a very dedicated, let's say, uh, training for safety purposes, and to understand the overall process and so forth. Um, these are again, I'll just give you a brief overview of the what happened in BP Texas refinery. It was a flaw in the distillation tower or distillation column, where the pressure was not sustained. And as you know, in refining, or in overall refineries, the temperatures can exceed very high. And if the pressure is not sustaining, the vapors, they can blast. And that's exactly what has happened. Since we are dealing with refining the crude, there were various fractions. The pressure was not sustained. There was a flaw in the distillation design, distillation column design, and that has led to BP's Texas disaster. I think 15 people lost their lives and so forth. And these examples, they're very classic examples that we have to consider safety and operational excellence in almost every aspect, specifically if you're dealing with bigger infrastructure and we're dealing with energy, environment, and how they're linked together and so forth. So this was one of the figures that I found from the this Texas refinery there. So you see the overall loss of lives were there. We have, you see the infrastructure is damaged, and then they have to pay in legal implications. They have to pay lots of fees as well. Now, what are the pillars we want to see as a general understanding of success when we're talking in terms of operational excellence? So we have to understand the core principles. We have to understand what are the real plant applications. What are we trying to achieve? We have to identify the challenges, and also we have to identify the solutions as well. So in terms of challenges, we say, in terms of heating and cooling, do we have the, let's say, right capability? Do we have the right storage? Do we have the right infrastructure? Do we have the right, let's say, capital? Are we managing the cash flow and so forth? So there are lots of things in terms of, let's say, process safety and operational excellence, and they go hand in hand. If we don't really understand the principles, then we are not able to identify the challenges. We cannot provide the solutions. So they have hand in hand, or implications as well. Simple process safety. We have to identify the hazards. Hazard identification needs to be there. It's a very simple matrix that what is the likelihood of, first we need to identify a hazard. what is its likelihood, what is its severity, and based on that, we can identify that it is a low frequency hazard or a high frequency hazard, or it is likely to be happen and so forth. When that's done, then the management has to consider that um, what are the practices they need to put in place in order for the overall process safety and operational excellence. Uh, then operating procedures, do we have them in place? And training and competency, that there are every step there has to be training, there has to be competent people to make sure that they're doing things in a proper way, and they're trained and so forth. This is a very interesting thing, which is hazard and probability uh, study uh, that we have to again identify. This, there could be different, let's say, calculations of it. There are different examples of it. There are different benefits and so forth. So these has to be considered accordingly. Um, so if we say risk calculation, we have to consider the preparation. The team has to review it. They have to identify the hazard, and they have to evaluate the risk and so forth. And based on that, we are, basically considering if it's uh, example of an overpressure in a reactor. Is it um, is it a major? Is it something? Is it possible? Is it something which is hard to detect and so forth? And do we have those inefficiencies are there, or do we have safety norms there and so forth? So this is something which is um, pretty basic for any industry that we're dealing with. So HACCP it has to be structured, it has to be it should be able to identify and evaluate um, operational issues in any of the let's say process plan. Then management of change. This is basically related to how are we documenting the overall process. Uh, do we have a certain approach in where we are identifying things, and then we see what are the incidents, what are the operational disruptions that are there. We review the risks, and then do we have a change? Do we have, let's say, risk assessments are there, or based on those risk assessments, we have to, let's say, a structured approach where we do approvals, we disapprove, again, we implement that, and there has to be a review process. Uh, let's say, another example of accreditation. When any accreditation body comes to a facility, they will see and think about what are we doing, how are we doing, and to back up, we need to have documents, and those documents have to be according to certain, let's say, protocols, certain SOPs, and we have to give an evidence that it's there. So in big process facilities, if you're dealing with petroleum refining, if you're dealing with manufacturing facilities, if you're dealing with chemical reactors, there has to be a chain of command. There has to be management in place where they can approve, review, and monitor on a daily basis, on a monthly basis, and see what have they meet the targets, what are the downtimes, do we have, let's say, if we have maintenance, for example, maintenance logs of these facilities, do we have enough, let's say, capital to cover up the costs? Do we have the, let's say, agreements or proposals in place for if this thing goes wrong, what are we going to do and so forth? So identifying hazard, then we need to implement these processes in order for operational excellence. Um, Operating procedures and training and competencies. This also it's an extremely integral part of the overall excellence. Where in any organization, if you're just sitting on one place, you're not learning, you're not growing in your career. Same goes with uh, these process plants as well. They have to upskill. The technology is changing. If in terms of, let's say, we are consuming energy to do a certain process. Now, if you look at 10 years back, the The sensors, they're more, let's say, integrated. They consume less energy. They're more, let's say, more, they give you a better experience. So they have to upskill, they have to upgrade their facilities every now and then. And also they have to upgrade the people who are there. They have to make sure that they're training and so forth. The training, the development has to be there. There's a proper support. We need to consider there is proper goal. We have to, um, the learning is there. And it again has an impact on overall operational excellence and so forth. So it's, if the people are competent, their skills are being developed over time, then it means that we are doing something right towards achieving operational excellence. This is something again I found very interesting there, that when we say operational excellence, there are lots of things that are there. Specifically continuous improvement. Every aspect of the process, there has to be improvement. Uh, you're committed to the overall excellence. You're making sure that your product is innovative. What process that you're dealing with, it is again in a safe manner. We have safety is number one priority. We are trying to exceed the expectations in terms of, let's say, delivery to the customers, government regulations, and overall in our let's say, just like we have our friends, similarly these process plants, they have competitors. So if we are doing things in a safe manner, if you know that the employees are happy, there is a good culture in that. So because of word of mouth, things will excel. And it looks very minor thing, but it has a significant impact on overall continuous improvement. So there has to be a culture of improvement. There has to be something called RCM, reliability centered maintenance system. Uh, it's lean manufacturing, Six Sigma. There are certain, let's say, we have to define it, we have to assess it, we have to again report things. These are core principles of Six Sigma principles. And then there's a Japanese word Kaizen, that's also related to, let's say, good behavior. And then we can link it with the overall operational excellence and so forth. In terms of reliability centered maintenance system, we first thing is operational excellence. Operational excellence comes with cost effectiveness, looking at making sure that we have the proper improved liability procedures in place. People are communicating with each other. There are proper documenting procedures. There are resources available, and you're looking at, let's say, clear objective. If the objective is not there, then it means that we're not monitoring things. It has to be monitored properly. Things have to be documented properly, reported properly, and then it would lead to a proper excellence in an overall operations. Any operations we talk about refining, we talk about drilling activities, we're talking about downstream distribution networks and so forth. Everything is linked with these major terminologies and so forth. This is another aspect of manufacturing model, where if you see, we have a continuous improvement, value stream, we have a flow, and then you're basically pulling things together. And then in the middle, you have a proper culture where we are respecting the people, we are promoting them, we are listening to them, we are giving them right resources, right skills, right safety equipment, and so forth. And we'll see that overall model, the manufacturing model, it's kind of it's a lean one. And if you take away any one element out of it, you will see that the overall model will get disrupted. For example, if you don't have value, and by value I mean that you have a product, and then you're making sure that that product is up to a certain standard. It has to be according to certain specification. If those specifications are not met, it means that we're not doing something right. There's no continuous process in place. If we see there is a discrepancy, we have to report it and we have to try to mitigate it. And the overall, everything is, these things are linked together in order for to achieving operational excellence. Um, these are Six Sigma, let's say, frameworks. We call it as define, measure, analyze, improve, and control framework. Uh, these terminologies, they look very simple. Um, but if you look into it or try to understand it in a bit more detail, you'll see that they things can be very simple, but we can make it very complicated. Define the problem. What's the problem? Um, if let's say your car is not working, there could be hundreds of things that can go wrong. Um, related to engine, transmission, related to electrical systems. So we have to define the problem. Where is it? Quantify it. What's the likelihood of it? What impact it has in overall problem? Then analyze that problem. How we can improve it? Um, the cause of it. Then again, here risk assessment comes very handy. Um, and then you have quality improvements, continuous quality improvement. You improve it, you implement the strategy. If that strategy don't give you the results, then you go back in and see and analyze it again and see where we go wrong. And then we have got proper control of the overall procedures, overall practices to get the excellence what we need, and so forth. So these frameworks, they're very, let's say, simple, but when you're executing them, uh, you see that there are lots of technical challenges that we can see. It's not as simple as this, but we might have a challenge of, let's say, a technical drawing. We might have a challenge related to extreme pressures, extreme temperatures that we're not able to see the root cause. We are unable to give the output that's there. So we have to identify, define, and control, and look and so forth. This is another way of, let's say, cycle for continuous improvement. It's a Japanese philosophy. It's change for the better. It's called Kaizen in Japanese. This is how you pronounce it. And again, it's about identifying. It's about looking back where things can improve, create the solutions, and in the Japanese culture, they test the things before implementing. They preemptly they see what can go wrong. If I implement it, let's say 5 years down the line, 10 years down the line, what could possibly go wrong, and do I have the mitigation plan there in order to do so? So they're proper. We have to measure and analyze results. We have to standardize the solutions, and it's again, as I said, it's a continuous improvement cycle there. This is just a very simple, let's say, graph that because of these integrated safety and reliability strategies, leadership engagement, reduce incidents, improve plant uptime, we have better safety performance. If we have better safety performance, that would lead to overall, uptime, or you can say there are lots of indicators that for improvement in terms of, let's say, operational excellence, in terms of output, in terms of safety aspect there, and so forth. And we can look into various different models of, or various different case studies around the world in process plants, in refineries, in chemical, let's say, manufacturing facilities. They can lead to lots of these integrations there, and so forth. This is another important thing, or let's say when we say integrated safety and reliability strategy, what exactly we mean by that? There are lots of things as simple as, let's say, we don't really bother about that problem. We can have a reactive approach. There is an effective approach. There could be a proactive approach, and there is an enlightened approach as well. So it's about the discipline. It's about realizing your mistakes. It's about having the processes in place, and then continuous improvement. I'm in academia for past almost like 10 years, and we have about 3 different accreditations that occur every 3 years. We have ABET accreditation, local accreditation, CAA, NQA, and then UPITO accreditation as well. All of them, they demand very rigorous documentation. They want to see we have the policies in place, and to back up those policies, are we actually following those policies? We have to give evidence of everything. For example, um, our graduates, um, when they go out, we have an exit exam, and that exit exam, it gives ABET an idea that we are looking at the quality of the graduates that are going out. Um, and uh, for each course, we have, at the end of the course, there are surveys. The management looks at those results and so forth, and then based on those results, they see what is the performance of the employee, what is the performance of the teacher, and also the performance of the students. So there are policies and procedures in place in order to improve the overall excellence, overall reliability, and so forth. So these things come with the personal attitude and also the organizational attitude, that do they have these things in place and so forth. Um, Now, a bit like last couple of slides related to the future of plant operations, what is going to happen, or what is actually happening right now. So you see, we have these fancy, let's say, technologies, artificial intelligence, machine learning, cloud computing. We have lots of data that we want to analyze and so forth. We have digital twins, just like RTsim. They're doing that. So the students can basically get themselves trained without exposing to the real environment. We have got AR, VR, augmented reality, virtual reality, remote monitoring, and so forth, Internet of Things. So this is where now the world is heading towards more automation, where there will be less and less human, let's say, involvement. Human aspect is going to be there, but there is more artificial intelligence that is going to take decisions. If you look around yourself as well, we as educators, we are involved in this AI a lot. We are depending on it. It's a good thing and also a bad thing at the same time. But we have to embrace it. If you don't embrace it, then it means that you're basically leaving behind. So in terms of digitalization, there's more predictive analysis, where rather than you're doing it manually, so based on analytics, you can do the predictive maintenance. Smart maintenance systems are there, artificial intelligence that can report, let's say, every 6 hours, every 12 hours, every 24 hours. So there's no need to do the rigorous working. So it's like a better in terms of plant operation and so forth. What are the key takeaways that we have? We want to consider. Safety is foundation of excellence. We have to consider continuous improvement, process optimization, employee engagement, data analysis, and technology integration. These are the 5 pillars of Six Sigma and also continuous improvement strategies. And in all 5 of them, if you see, if we have clear objective, if we have clear defined, what outputs are, what resources we have, what processes in place, then do we have the right technology? Are we dealing with, let's say, every now and then we're improving and so forth? There's no way that you cannot excel in managing the plant, in managing the facility, and um, you know doing things in a proper way and so forth. Um, there are a bit more, but I would like to wrap up here. These are different environmental considerations that we have to consider that are linked with that. But I think I don't want to bore you with another 15 minutes or so. So I'll be happy to take any questions. I think the time is almost there as well. So in the last 5 minutes or so, I'll be happy to take any questions, please.
Of course, you're not making us bored, Mr. Muhammad. Actually, the lecture was wonderful. Thank you so much for this useful information. I'm sure our participants will take it in their mind. And just while they writing the questions, I have one question to you. What is your advice to our participants who actually want to have a future career in energy sector, who probably will go somewhere to work? Like, for for you as a person who also as a professor at university, what is the advice which you usually give to your students, which can be in common but also a lot detailed about energy sector, if you understand me clearly?
Yeah, I got you very clear.
Yeah.
The advice that I always give to my students is, have a clear, be clear in your mind that what you want to be. Let's say you study 4 years. In those 4 years, you go through almost more than 60 or 58 different subjects. Each subject is a speciality in itself. Like, for example, we are teaching petroleum engineering. We are dealing with, let's say, from drilling, reservoir engineering, well logging, well completion, reservoir simulation. Each of that, it's a, let's say, a domain. You can be an expert in that. So have a very clear objective, that what inspires you, what do you enjoy most, and then build your resume around that. Let's say if somebody is a mechanical engineer and he's good in drawing, get the skills that are specifically related to drawings, and softwares that are related to that, and try to see what companies are offering those services. And I always give this advice to my students as well, that look at the job description. For example, it's a petroleum engineer. What is the job description of that? Look at the job advert. You can find it on LinkedIn. You can find it in Google. Um, what work they do, and then if you're studying that, try to relate that work. Ask your instructor that how this thing is done. So when you graduate, they're not looking at your degree. They're looking at a person who's capable of doing things, who has these skills to do so. And another very important aspect of certifications. You don't have to have, let's say, these days there is a norm to have a bachelor degree. But if you have a right skill, let's say, you if you're I'll just give you an example of quantity surveying. It's a very minor thing, but if you have that certificate, you can work as a quantity surveyor, which is a junior position. And if you work a couple of years, you can be a senior, and then could be let's say, a QA manager, and so forth. So don't limit yourself to, let's say, these. Don't entangle yourself. Have a very clear thing that what you want to do, and the job description has to be read very properly, very carefully, and uh, start doing things. Don't rely on, let's say, the things will come up and you will do so. There is an opportunity every time. We have to improve ourselves. As I said, in 10 years, I did my master's in 2012, and these 10 years we did so many certifications. We did lots and lots of, let's say, if you don't do that, it's part of our appraisal every year. If we don't continually improve ourselves, we get penalized. We are asked, we are questioned. And you cannot stay in an organization if you don't improve yourself, if you don't improve your skills, if you don't participate in different events, if you don't publish papers, if you don't go to these conferences, journals, and don't present your work. So you're basically stagnant. And one last thing again, we have a very clear objective, very clear mind, that do you want to be a drilling engineer, you want to be a logging engineer, you want to be a mud logger, you want to be a directional engineer, directional drilling engineer, and work for it, and have right skills for that very job. Thank you.
Thank you so much, dear Mr. Muhammad. Really, it's a wonderful advice. I'm sure, guys, please write it, I think, in your notebooks, put it to your wall and look to it every time, because it's really important. And I couldn't miss the opportunity to tell this, but with RTsim, you can get most of these points. So, guys, if you have any questions, actually, we have a question, dear Mr. Muhammad. Can I read it to you right now, because we have them in chat, so I think it will be easier for you. And one of our participants, Mr. Ibrahim, he's asking, thank you for the insights. Sir, what certifications would you recommend for an early career process engineer?
So for the process engineer, you need to see, let's say, if you look at the Upito website, they have different specifically related to process plants, or process operation engineers that that are designed for that. Let's say you're talking about a separation process, or we're talking about reactor design. So you have that core competency, that how to run that plant. Let's say this is a separation plant. How are you going to run it in a safe manner? You're able to read these PNID diagrams. You're able to let's say, um, operates, not like in a full-fledged way, but have the skills, right skills to do so. So the Opito is a right platform for process engineers. We are offering at Abu Dhabi Polytechnic, we are a accredited center, and we are offering global 2 certification as well. It is specifically for the students. We are working towards the offering assessor trainings as well. But what I feel is, for the process engineer, Opito is the best platform to get yourself. And I would strongly recommend to please look at the Opito website and see there are lots of certifications that you can do. For example, working in a confined environment, working at heights, operator competency certificate. You can, once you do that, you can do, let's say, competence assessor as well. So these are the things I would say for the process operator safety. And also, if you have, if you do, um, let's say, have software skills, for example, Aspen ISIS, that's one of the best. And then Yokogawa, they have also a very good software which tells about the operations, how the specifically processes design and so forth. That's also a very good skill. Try to look into that as well, please.
Much for the answer. And we have one more question in chat. You talked about AI. How far away are we from their deployment? What does the future look like for human participation aside from software developers?
Human participation is going to be there. What I feel is, artificial intelligence is there, but we can imagine. Artificial intelligence cannot imagine. So that intelligence is always dependent on human imagination. It's going to take away some of the burden from the humans. But this is what my understanding is. That's I always think about. It has impacted us in the past couple of years, specifically couple of years where there is a boom. It has impacted the way we work, the way we communicate, the way we teach. But it is unable to imagine. It's all this artificial intelligence is based on data which somebody has already imagined and has fed to these models, and they give based on that. So until that imagination is there, it's this intelligence is based on that. So they're working on let's say automation is going to be there, the reliance is going to be there, but I don't want to discourage you in any form of way where the artificial intelligence is going to take away the jobs. No, it's not going to happen. It will complement us, it will help us to improve the jobs we do, and the way we do things. And the implementation, you see the data centers are being built all around the world, and they're being built so that there's artificial intelligence is going to be in every, let's say, aspect of our life, in hospitals, in industries, in manufacturing, in, let's say, you name it, it's going to be there and so forth. But the the imagination aspect of it, if you think about it, it's going to be with us. It's never going to be in artificially intelligence there and so forth.
Absolutely true. Thank you so much, dear Mr. Muhammad. I'm not gonna take you more due to Ramadan month and in general. Thank you so much for your time. Thank you so much for this useful lecture. We really appreciate your time and thank you for staying with us. I'm sure participants who will watch a recording also will like the lecture. If you will have an opportunity to share with us your presentation, it will be super appreciated and super useful.
Sure,
Yeah,
I will share the presentation right away.
thank you so much. And I will share with guys in chat. Thank you so much once again. Thank you, really. It was wonderful experience. We wish to collaborate with you more.
Thank you
And
very much.
according to reactions, our participants really liked the lecture. And if you want to see Mr. Muhammad again, please write in chat.
Sure.
Thank you so much.
Thank you very
Thank
much, guys.
you.
Thanks a lot. Have a great day. Thank you.
Thank you. So we can finish right now. Thank you, guys. once again for joining us. It was wonderful. Thank you for all your connections and bye bye.